Hello, and welcome to the Women in Data Science series of the Shelley Show. This is our 14th episode. So time has just flown. Suddenly we are on the 14th episode. So thank you all for your love and affection to the series. I'm Shailendra, and you're watching this simulcast live on LinkedIn, Twitter, Facebook, and YouTube. I hope you and your family are safe and are doing well in this time of COVID-19. Hopefully you're staying indoors as well. Every fortnight, we bring the leading ladies of data science to this platform and understand their point of view in the data science world. So if you know a leading lady of data science and want to hear their point of view by featuring on a roundtable, then please mention their name in the comment section. Now, if you have a question, then please write your question in the comment section, and I will definitely take that question and put that to these leading ladies of data science. Let me start with a question. So I want to add a question to the audience today as a starting point. And the first question that I want to put on to you is, and there are two ways of doing this. One is, what do you think is the level of sophistication of analytics in your organization? So there are four levels of sophistication. You've got the data integration, descriptive analytics, ad hoc analytics, and predictive analytics. So what do you think is the level of integration at your organization, level of sophistication at your organization? You can do it in two ways. One is mentioned in the comment section, or just take your phone, open the camera, scan the QR code. It will take you somewhere where you can just respond. That way we can collate all the information and see what's going on. So this is the first question, and I repeat the question: what is the level of analytic sophistication of your organization, whether it is data integration, descriptive analytics, ad hoc, or predictive analytics? Also, please don't forget to like this video so more and more people can watch and learn from this episode. One more thing that I've learned, that if you're watching it on Facebook, what you can also do is you can share it with the groups that you were part of on the Facebook, so that you can be so more and more people can learn from it. More people can see in those groups as well. Okay, very quickly. Let me not waste any time and quickly bring the guests to you. My first guest is Dr. Rupanjali Chaudhury, who leads the data science team in Cerner Intelligence, India. Her passion is to work in the healthcare domain and make an impact on millions of lives. She is an ICMR fellow and did her PhD in bioinformatics from IGIB and postdoctorate from IISc. She works extensively on AI ML solutions in the healthcare space, involving medical imaging, medical signals, revenue cycles, developing machine learning, deep learning, and forecasting models. She's responsible for delivering healthcare IT solutions to clients. She has a patent and several publications in international journals to her credit. She enjoys mentoring buddy data scientists. So all those young data scientists who want to be part of the, who want to learn from her, well, you need to listen to her and maybe reach out to her as well. So without any further ado, let me bring her to the show. Hi, Partley. Welcome to the Shelley Show, the Women in Data Science series. How are you doing?
Yeah, I'm good. Thanks for having me on the show.
Good stuff. So Rupanjali, you said your passion is around healthcare. Can you be a bit specific? What part of healthcare, what part of area do you look after and you're passionate about?
Okay, so I would say, like, since my subject area was bioinformatics, so I did my master's, my PhD, my postdoctorate in bioinformatics, which is actually computational biology. So it brings into, we develop, the subject is more about developing computational algorithms, tools around your life sciences and healthcare. So which goes hand in hand, right? So that's how it all started. And And now when I'm in healthcare, I feel that accomplishment because my subject area was that, and I'm working around that, right? So it's more about like how healthcare impacts millions of lives, right? So it's like it's more of a community service where whatever we develop, it goes to the people. And in these COVID times also, right? So these algorithms, they some or the other way, they're helping people. They're preparing and helping them to make some smarter decisions and save millions of lives. So that's what brings passion to me, and the work which I do, I feel really good about.
Okay, good stuff. Just give me a moment and I'll bring the other guests as well so that we have a quorum and we can have a larger discussion. My second guest is Ranjani Mani, who has more than 13 years of experience in setting up and growing data science teams, product management, pricing, customer experience are some of the things that she looks after. And she's worked across companies like Oracle, Tata, I think it would be TCS, we'll ask her, and Dell Inc. She currently leads a 15 plus member team, global team of data scientists and engages with cross-functional teams across product management, engineering, technical, and C-suite executives to solve business problems in customer experience through end-to-end solutions at VMware. So without any further ado, let me bring in Ranjani. Drum rolls. Hi, Ranjani.
Hi, Shailendra. Hi, everyone. Great to be on this show. So thanks for having us. Yeah.
Welcome to the show. So tell us about, you said that, you've got a team of 15 data scientists. Are they stationed in Bangalore or you look after people around the world? How does it work?
Yeah, we actually have a cross-functional team. So my team sits out of Bangalore, Sofia, which is Bulgaria, Costa Rica, and Palo Alto, which is where we're headquartered, right? So true to a company, it's a multinational company with a global presence. So we do kind of engage. And in the remote times, I think we find it easier because we have always been a global team, right? So yeah, that's the structure of my team.
Good stuff. I always thought that we've got more data scientists only in India. So it looks like that we've got Bulgarians also doing some good stuff and other parts of the world also.
Absolutely, yeah. Great skill sets across the globe, right? So I feel very fortunate to be, leading them, and I constantly learn from them each day. So yeah, leading this team.
Good stuff. So just give me a minute and I will introduce our third guest as well. But before, to all of us, before I get on to bringing in the third guest, for you to view this episode and other episodes that I run on Emerging Technologies Live, I would request you to follow me on LinkedIn if you're watching it on LinkedIn so that you can be alerted when the next session or the next episode is on. If you're watching me on Twitter, please press the follow button. If you're watching it on YouTube, press the subscribe button and smash the bell icon so that you can be alerted when the next episode or a video is uploaded onto YouTube. All these episodes plus the previous episodes are available on YouTube. You can watch them at any time if you plan not to watch them live. Also, please don't forget to share this with the Facebook groups because I think there are lots of groups which are focused on data science that can learn from these leading ladies. So finally, I'll bring in the final guest. We have Kavita Dwivedi, who is a data scientist with around 13 plus years of experience, having worked in pre-sales, solutioning, and delivery of data science projects. She has been a leader she's been in leadership roles for the past 5+ years and has worked with companies like Fair Isaac, Experian, Accenture, Vodafone. So she's worked at Accenture. I need to ask her where. Vodafone, Infosys in the past and currently heads the data science team at Infinite Sum Modeling. She has been setting up and managing data science teams with senior data scientists and has been involved in completion of projects with ROI benefits to clients. So without any further ado, let's bring in Kavita. Hi Kavita, how are you doing?
Yeah, doing very well, Shailendra. Thanks for having me and excited to be part on this forum.
Good stuff. So Kavita, you were part of Accenture as well, and I too was part of Accenture, if you remember. Where and what part of the business were you?
I was part of the GTIN consulting team and I was within the banking vertical and working with the team in Gurgaon and Bangalore simultaneously. I was based out of Bangalore.
Oh, okay. So did you ever work with Sanjay Sharma?
Sanjay Ojha, you mean?
Sanjay Ojha, yes, Sanjay Ojha, Sanjay Sharma.
Yeah. Sanjay Ojha sir, I have worked with, yeah.
Okay, good stuff. Good stuff, guys. Let's quickly jump into question and answers and getting your point of view on data science. But before we get there, I need to ask a question and I need to see how I can do that. I've never done that. This is the first time I'm trying to do this quiz part as well. So let's try and do that. So let's ask a question to the audience. And this time the question is, the question number 2 for the quiz, what's the topmost skill to be a good data scientist? Is it being a programmer, a statistician, problem solver, or out-of-the-box thinker? So what I want you to do is, if you know the answer, if you think the right answer, what you think is the answer, please put that in the comment section, or just take a picture of this, open your camera and scan the picture out, and it will take you to a place where you can answer the question and tick one of the boxes. I'm still trying to figure out how these live sessions can have a polling environment. It doesn't at the moment, so we're still in the nascent stages. There are new technologies coming up as it goes. So let's talk of, while we're looking at these questions and people are trying to answer, let me ask you this question, guys. Process, the data science process. So have you seen that the data science process has now become a formalized end-to-end process, or do you still think that it is still going on from that, hit and trial methodology which we know for the past few years? What do you think, Ranjani? I'll start with you.
Yeah, sure. So first of all, I think over the last decade, right, there's definitely an increased focus on AI across organizations. I think the CG report, which pegged that around 90% of enterprises agree that AI represents a huge business opportunity for their companies, right? This therefore brings us to the role that data science plays within organizations. It's kind of moved across from building intelligence reports, right, exploratory analysis, to building and deploying ML models, to enabling data scientists with repeatable processes, right, which will enable analytics capabilities, and eventually to aligning your AI strategy with the business strategy. So this is kind of like a general maturity model, so to speak, right? And again, various organizations may be at different stages in this maturity. But I think it's critical to understand that the output of the models do not drive impact, right? The process changes and actions which are taken based on it is what does. So I think when an organization starts, they may hire more generalists versus specialists, right? And then as they move ahead in that curve, they get differentiated as the team deliverables mature. So, and so do the platforms for deploying the models, right? So in kind of the point I want to underscore is for organizations looking at getting value out of analytics, AI doesn't exist in silos, right? It probably needs to be considered as part of the business transformation strategy, and enabling processes is critical to realize value with the AI.
Mm-hmm. Okay. Rupanjali, what have you seen? What kind of, do you see a structured process, or is it a kind of hit and trial still going on there?
Okay. So actually, what happens, like whenever I feel like some organization starts with a data science team, usually they will start with some research, or a small team which will focus on some of the POC use cases or research, right? And then when you want to grow it and want to make it more client deliverable, so the projects which we need to deliver to the client, then definitely it cannot be more of a hit and trial, or the POCs need to be converted into what the client should get value out of it, right? So that's the point. I think it needs to be more structured, and the companies definitely they work. We all see right now the AI tools, they need to reach to the clients. So the process has become much more structured now. So having different teams, like you will see like teams which will host the data. We will have teams which will also do the data science. Then you will have the interface kind of team which will provide some good interfaces by which the clients can interpret the solutions, right? And so it has moved to a much more structured format, and which is required, definitely.
Okay. What do you think?
Yeah, so what I have seen across this years of my working in different organizations is most of the time organizations try to push for a process-driven approach. But frankly speaking, what I advocate is data analytics or data science, as we call it, is more of an art rather than a science. And when it is an art, there can be no process assigned to it. So what I say is that different steps has to be done in a more iterative manner, and the results or the outcome of the first step defines your second step. And if that is the process in which we are working on a data science project, I hardly see a time when we can kind of completely put it into a process box, or even say in a mode where people say that, okay, let's try agile in a data science environment. All of these is only possible when you have a set of defined steps. And as Rupanjali put it very rightly, once you have completed the project and you are in an implementation phase, then talking of some of these things like bucketing different areas of work across teams, and then managing and implementing the model, validating and monitoring the model, those all are steps which can definitely be kind of put it into a process. But as far as building and developing models is concerned across different domains, I hardly see a scope of standardizing the process. The other very important part that we need to understand is what goes behind these models. All of these models have data behind it, and data across organizations is very, very different. So until unless we can standardize the entire data collection process or the data which is there with the organizations, I don't see that we can put everything into a process right now. I am a big advocate, and I am generally the one who speaks against putting into a process into a data science project. So I'll continue to hold my view on that.
um, and it is good to have a very a very strong opinion in this particular case. And I'll tell you why. Because of course, I usually say, you know what, we Indians can be very good data scientists, and I have this debate with my wife most of the time because she says you're very unstructured, and I tell her because I've grown up being a data scientist. Well, the word data science wasn't there when I used to do something like this. It used to be called it wasn't even called analytics at the time. So as we're growing up, we're changing names. But the success, the reason why I'm successful is because I'm unstructured, because my thought process is not structured. But having said that, and that is very important for analytics or data science, because if you're unstructured, you will think outside of the box and you will do something which is not processed. Because if you keep on doing what you're doing, you'll be keep on getting what you're getting, right? Um, and that's where data science is different. Having said that, there needs to be a formulating, overarching structure to the process, and that's what I learned when I joined Accenture and I worked at Accenture. Because prior to that, I came from corporate, and I was running many analytics professionals, and I said, well, let's take a problem, try solve it. So the idea was, when I came to Accenture, well, we actually formulated saying, what is the problem that you're trying to solve? What is the outcome that you're looking for? What data will be required? What will you do with data? What model will you build? What will be the output? And then if that output meets the outcome, fine. Otherwise, start from the scratch. So basically, it is a overarching structured process. But within the structured process, you need to be very unstructured, because if you're not unstructured, you're not able to. So that's my point of view. In my opinion, maybe absolutely wrong, but that's what I see. Before I ask you one more question, I would like to state one thing, and that is that at the moment there are more than 35 people watching this episode. So guys, if you've got a question, put that in the comment section, and we will definitely take that question very soon in the audience Q&A section, which is just after my questions finish. Okay, one question to all three of you. What do you believe is the missing ingredient within the current approach that you see that data scientists take? And if there is an approach that you thought, or there is a process or component of that process that would have come in and would have made a huge difference, what that component of that process would be? Can you give me a bit of a thinking? Ranjani, let's start with you.
Yeah, I can probably take that, right? So I kind of agree with what both of them said, right, Kavita and Rupanjali, we cannot have the process for the sake of having a process, right? But then the process is supposed to be an enabler. And to your point, right, Shalinder, I agree that while you provide the liberty to think outside the box, the larger structure to enable it is important. For example, we use agile methodologies. We have a clear defined Jira process, right? We run our projects on sprints. And why is this helpful, right? The worst thing which can happen for a data scientist is he or she comes in and there's a blocker, right? And he doesn't know what to do next, or she doesn't know whom to approach next. So I think enabling the team is to have clarity in terms of what they should be doing so that they can progress ahead. So having that agile process has helped us tremendously, right? Because they're not waiting on someone to happen. I'm not being the bottleneck over there. So I think that's helped us tremendously.
What do you think, Rupanjali? Any ingredient that you think which would add a huge benefit to the process which is not there at the moment?
Well, one thing comes in my mind, like when we talk about scalability of these solutions, right? So that is the place where you need all the things to be structured and integration, and the teams should be working closely to each other to make that happen. Because when the clients need those solutions you need the solutions to be portrayed at a much more higher, structured and scalable format, right? So which will need the data to be hosted properly, which will need the second flow, like your data science part should be very well integrated with the domain understanding and the features which are coming important out of the model. And then what their client exactly wants and how do we portray them the results, because they not only would want a black box model, they also want to know like which features are impacting my model, so which are actually our predictions, which features are being important and how their impact, what is their impact, like positive or negative. So they don't want these black box things. So two things: one is scalability, second is interpretability, right? So this can be thought of like a missing component, which if companies do think about, it brings the entire thing in much more process format, and it's much more scalable, I would say.
Okay. What do you think, Kavita?
Yeah, in my view, I think one thing which can drastically change the way data science is being used within different industries is that the business partners needs to come throughout the process of building the data science models, and they have to be working with the analytics team with a very integrated approach rather than coming in. Say small pockets and kind of giving their suggestions and going back. I think there is a lot more integration that business people working with closer with data scientists can build a lot more richness into the model. Because although being a statistician and a data science modeler myself, I do feel that the domain knowledge and the domain what do I say, domain things that come out while building a model is very, very important as part of finalizing the final model. So I think a lot more integration is required, and that's where I think organizations need to look into the structure in which they have laid their data science team. The data science cannot be a silo within an organization, and I do feel that the data science needs to be embedded within teams across the organizations, be it the data team, be it the IT team, be it the process team, be it the business heads. I think everyone needs to have some head of data analytics working with them closely, because even to build a very good model, the entire process of data collection and the process improvement needs to go hand in hand, especially if you're looking at a cycle of data science models that you are going to implement within the organization. The improvement depends a lot on how business is using it and how well the next cycle of the data science model can be built in. So I think the business integration needs to be thoroughly looked into, because I know organizations which function as a very proudly as independent analytics unit, but it doesn't always work that way. So I would want to see more and more embedding of business and data analytics team within organizations.
Absolutely. And if any of my previous mates and people who have worked with will be watching this, would be very happy to hear you, Kavita, because we always say that business should be engaged from day one, because it is. They were saying one of my PhDs a long time ago. He told me, Sherry, if I build you a model that is going to return $1 billion, but it is not executable, what's the point of having that model? And so if I don't get there are few things, right? The buy-in of the business, which is very important because they want to know where did you come up with that idea. Secondly, how have you come to this conclusion? And have you not done something which the business has already tried in the past? Because sometimes data only tells you what you've already done. So, how do I make sure that all of that is sussed out beforehand? So, and if that model if the business thinks that's my model, then they will execute it quite quickly. So how do you make that particular model or that particular project from a project of the data science team to the business project? So there are two things which we've seen successful. One is that the data science team is sitting within the business team. It's not part of the IT team. It's very lucrative to put the data science team in the IT team, but the best place for them is the business team, because if they're in the business team, then it is part of the business that they're doing. It's business as usual that they're doing stuff. So I think that makes a huge difference. Any ideas on that? Any thoughts on that, guys?
Yeah, I think it is crucial, right? I would say it's kind of a deal breaker, what Kavita just mentioned. You cannot have AI as an afterthought. It needs to align with the business strategy, right? So I think absolutely agree with you, Kavita. So when we do work, right, we work alongside with all of these different teams, the product team, the management team, the engineering teams, in terms of collaborating and building the solution together, right? So even if it does sit outside of the business, I think it's critical that they function together as a group, and that's what makes or breaks projects.
What do you think? What do you think, Rupanjali?
Yeah, I even agree with my co-speaker. So it's true. Like we have to have these units going hand in hand. It cannot be in silos. So many companies, like we see that there are some analytics unit, or even like they have a small group of data analysts and data scientists who are working all together in silos, and some. So it has to change. So all the process, they should work hand in hand with the other units, and domain understanding again is very important. And be it in any sector, we have so many different business units which work on specific domains, right? So when the use case comes, those analytics teams has to work closely with the business units, go deep into the domain understanding. That's when you come up with ideally what kind of feature engineering again is a very, very important thing in our domain. So once you try to do feature engineering, definitely you have to have that domain understanding. Without that, you cannot think of doing a feature engineering. So all things has to go hand in hand, and then the outcome which you are going to predict, so is it aligned again with the business or not? So depending on the use case, right? So these are very important aspects, that it cannot be in silos. It has to go hand in hand, and all needs to work together.
Okay, perfect. Before I get to the next section on skills, a couple of things for the audience. Guys, if you've got a question, please put that question in the comment section, and I'll definitely take it in the audience Q&A. But so I'll take all your questions, definitely. Please put that in the comment section. Secondly, please like and share this so other people also learn from these beautiful leading ladies of data science as we go forward. And there are 13 other episodes which are in the YouTube channel which I run, so you can go and watch all the others. We've got now what? So you are number 40, 39, 30, no, 40, 41, 42. So I've got 42 women in data science on this series. So, you've got another 40 point of view of another 38 different ladies you can watch on YouTube. Okay, before I get to the next question, I'll just put this question out again for the audience. Quiz time wise, guys, which is the topmost skill you think is there to become a good data scientist, programmer, statistician, problem solver, or out of the box thinking? You can answer this question two ways. One is put it in the comment section, or just take a picture of the scan me and it will take you to the area where you can actually answer the question. I think that's a better way so that we get a good idea of where we're going on. Okay, guys, while people are answering these questions, I would like to talk about the big elephant in the room, and that is the skill set about data scientists. And I have this theory that what has happened over the years is that people who were doing data management or data wrangling have changed their titles and have become so-called data scientists. See something like that in the market when you interview people, when you get to people and talk to them? Do you see a lot of people who've done some kind of SQL writing and now they're calling themselves data scientists? What do you see? I'll start with Kavita this time.
Yeah, and I think that's the biggest problem the data science industry is currently struggling with, Shalendra, that everyone claims to be a data scientist, even if they have kind of worked as any small part of a data science project or even not worked on one. I mean, if you looked at LinkedIn, there are so interesting titles that people have in data science space: avid data science thinker, data explorer, data discoverer. I don't know. I mean, I'm so amazed to see where does this title come from. But having said that, I think data science is a very serious business. And when we are talking of building a data science models, we are actually talking of benefiting the business in leaps and bounds. So we are looking at benefits which will go in multiples, right? Not in a small number of the. So when you have to work in a project like that and you have to get benefit for the business, I think skills becomes very, very important. And for me, what I feel is that data science itself can be split into two, three main areas. One are the people who handle the data, who are the data engineers or the data people that you call him, the BI people in the old world that we were earlier being referred to people. And then there are the set of data scientists who actually build models. And these should be the people who should have a very good knowledge of the statistics and the theory behind machine learning models, what goes behind the understanding of different kind of models, which kind of algorithm to choose, what kind of problems can be tackled using what kind of algorithm. Because not, what happens today is that a coder, if he's given a data science problem, he has a set of codes of starting with building a decision tree, then a random forest, and then a gradient boosting, and then a neural network. And he just runs all of these because he thinks, or he or she thinks that, yeah, this is the way a data science model is built. But unfortunately, this is not the way. A lot of process has to be done before even getting into the model building. And I find that a data scientist should be engaged in the cleaning up of data a lot. And by
Yeah.
cleaning of the data, it's just not doesn't mean the tireless effort on the data. It also means understanding your data, talking to your data, and exploring different aspects of data, so that when you are in the stage of model building, you exactly know which variables has to be used in which way in a particular model. So I think that part of the skill is very, very important. And then, of course, there is the third end of it, who are the model implementers. And these will be the people who can have a lot of data engineering skills, building of pipelines, etc. in Python, who can help us implement the model. Nowhere I'm saying that any of this is not important, but I think it's very important that people who think that they want to create a space for themselves in the data science world need to clearly understand and figure out which space they want to be and where they want to exist. And of course, overlaying these are the consultants, etc., who are more of, as we talked about earlier, out of the box thinkers who can think actually what kind of solution needs to be built for this problem. So I think, yeah, I mean, you raised a very pertinent problem that is currently being seen. Not even the profiles. I mean, even if you see the JDs, they are all over the place. So that's very interesting to like see that even the people who are trying to recruit are not very clear what kind of people they are looking at for their projects.
Okay. What do you think, Ranjani?
Yeah, no, I was kind of smiling because I empathize with whatever you're saying, right, Kavita? So maybe I'll kind of double click on that roles which Kavita spoke of, right? So, yeah, you have data engineering skill sets, right, where they kind of connect with people, do the data manipulation, build out pipelines. You also have people who will be interested in doing business intelligence, not just reporting, but also, consultative deep dives, trying to understand what the data in itself is, right? Then you have the predictive prescriptive analytics piece, and then the deep learning and the neural network. It's kind of like this entire um, set, right? And I think the key is data scientist as such is a very loaded term. So there are very different types of profiles which falls against this line, right? Now, identifying what your skill sets are and aligning them to opportunities you seek, I think is very critical. So for example, you might have people who are very good at storytelling, right? Some of them are very good at translating the business requirement into a technical solution. Some who want to explore working with data architects, some who are very good with automating backend pipelines, some who want to explore deep learning models. So all of these are different niche skill sets, right? And some people may have a combination of all of this. So I think what's important is to identify what interests you, right? And work towards projects that amplify your strength. And maybe I'll kind of conclude with the second point, right? Which is relevant across professions, not just in data scientists. It's from this book. It's called Lynchpin by Seth Godin. Highly recommend the book. So he talks about how if you have to become indispensable, right, to your organization and be a linchpin, you need to think about what makes you indispensable. So if all you can do is code very well at Python, there are always going to be other people who can replace you, right? Who can do this better. So getting back to the point, right? What is it that you need to do to drive value? How can you humanize analytics, right? Think about how is it that business is going to use it? Can you think about the problem you're solving rather than just saying, okay, let me do A, B, and C, right? Your value, therefore, I think lies in humanizing this and remembering that AI, ML models in itself are useless if humans cannot or do not want to use them, right? So I'm going to conclude with that.
Okay. What do you think, Rupanjali?
Yeah, so as I totally agree what Kavita just mentioned and even Rajni mentioned. So there are a lot of profiles which we see nowadays, and people, all of them want to be called themselves as data scientists, right? But we do see the skills is again very important. Data science, as I feel like I'm more from a research background, right? So I feel that data science really needs a lot of research and domain understanding and understanding the use case particularly and working very closely with that. So it needs a lot of research, right from the looking at the data, right from engineering the features, right from choosing the set of algorithms, doing the exploratory part, which needs a lot of thinking again, like how do we combine the variables? Do we come with what are the dummy variables which we can think of? So so much of research required, and you need to have passion for that. And it's not only passion right from the domain, you need to have a passion for the technical part of learning and understanding those algorithms, learning the maths behind these algorithms, then coming to a place where you can choose the best algorithm and then go with the what the end use case is about. So you need to have this passion to drive this entire research part and come up with that kind of skill. So if the passion is there, I think that is a very important piece, and someone has to have all these pieces to actually call themselves a data scientist. And one more very important thing which I would say, like again, it depends on different organizations, like what kind of data science teams they have. So you will see sometimes that some of the teams work in a very core niche research areas. So a computer vision team. So if you say computer vision team, they usually will work only on the deep learning stuff with medical images or any like images kind. And you really need to understand in and out of deep learning, and deep learning itself will have a set of multiple algorithms. Similarly, if you say NLP has a lot of different algorithms, and even now there are some of the very new techniques which have come up. So this again depends on the niche area. So when we recruit, it depends like which kind of team the person is going into. So where is exact that core kind of research expertise required, where you don't need them, you may need just a process kind of like where you have some of the like predefined, some of the POCs has already done, and you need to amplify that and come up with integration pieces all together. You have to drive that, maybe you have to enhance that. Right, so in that case, the skill set will be a bit different from what the niche areas of each of these, like time series or your or maybe your NLP, your deep learning and core research kind of algorithms are required, or where you want to enhance and put the entire process and put it in a nice scalable format to the clients. Right, so there's a difference in which kind of teams which we are looking for, and the skill set will differ based on that, definitely.
Okay. But that's a very good point around the kind of structure that you have within the team. you can't find all these things in one person. I think that is another thing that we've seen. A lot of people expect that the data scientist is going to do everything for you. And then, so when you look at those, and then, I'm sorry, but I find this really amazing that you see all those influencers who've never done anything on data science and are influencers in the market. They put those infographics which says to become a data scientist, you need to do this, you need to have Python, you need to have. Well, when I look at that chart and say one person having all of that, how many lives will they take? Because you want a person to be a very good data wrangler, a very good statistician, and very good communicator. All these three things in one person does not exist. And it is, I beg, if I can get one person doing this, who's capable of doing this, I will walk under their legs. Impossible.
Yeah, which reiterates why we need to have a good resume, a JD, right? To the point which Kavita made, I think. I think it's pertinent for hiring managers to define what they exactly need, right? And make it not generic JDs for roles which they hire for.
Exactly, that's me. So same. I also feel like JD has to be defined, like what exactly skill set you are looking for. So that is very important.
But to your point, I'll say one more thing. Who writes that JD is very important as well. That JD is written by the HR guy who has no idea about what data scientist does. And to be honest, and I also have seen that it is a long story. So it starts from the top. The person who is defining the data science team does not know who's getting in there to run it, right? They get someone from their IT project manager, Raja, you start running my data. You're a good data scientist overnight, and then he starts hiring people who, first of all, he doesn't know what to write the JD for, and so he's dependent on HR. And what HR does is looks out at various other job descriptions and tries to bring all of that into one. And then when the interview happens, but before the interview, when the CV comes in, they start doing control F, and finding out for those words like SAS, Python, R. Well, I'll tell you, when I was setting up the team, my teams in the past, 1 year I had 200 interviews. And the HR was so frustrated with me because I just wanted to interview. And I told them my job is to reject them, let them prove them right, let them prove me wrong. And 200 interviews because people who had no idea about analytics in those days, they had written a SAS report and they were presented to me. The reason for that is because my job description said that I needed someone who's done SAS, who's done analytics in SAS. The SAS is so big. You can do data management in SAS, and that's also SAS. So what HR does is it looks for control F, SAS. Oh, he's done SAS. That is one problem as well. So it is a function of a lot of things, and I think we need the right people at the right place to actually run that. While we are getting to this, I think I should put that question again, which is what is the topmost skill to be a good data scientist, whether it is a programmer, being a statistician, a problem solver, or out-of-the-box thinker. Let's see what people have to say. Having said that, I would ask you guys, while people are answering that question, what do you think? What advice do you want to give to the budding data scientists? What should they focus on? Because there are lots of people who are budding data scientists watch this episode as well. And what do you advise them? Should they focus on being a good coder? Should they understand the process? Should they understand the outcome? Should they understand the domain? Should they get the domain knowledge of the industry? What should they focus on? And what do you think should be done? Guys, I'll start with Rupanjali.
Yeah, Shalini. So these things which are mentioned over here, none of them is exclusive of one another, right? So I would say someone who is aspiring for a data scientist, very first and foremost thing, they should have passion for data science, passion to look at the data, connect it to the what is the problem is about, how do they really want to solve the problem, how they are going to solve the problem. So they have to have a passion and hunger to look at the data, look at the all the pieces. There are so many pieces when you have the data. After that, how do you actually do the exploratory, how do you understand which of the algorithms are important. So again comes the technical piece as well. So they need to have understanding or a technical hunger as well to be a good coder, as well as like your Python or R, whatever language. They should have the hunger even to go ahead and implement those. Like writing a code itself is again a big art. Like how do you write modularized code, and how do you, it's not just about like writing anything or trying out anything in scratch, right? So again, like what is the thought process you're bringing about it, and when again you try to combine the features or some feature engineering there, again that your coding, your technical skill really matters. So it all, nothing is exclusive of each other. All the skills are important, and a person who really has a passion to solve a problem and has hunger and to go for the data understanding and solve that problem from the business use case should actually look for that and should have all the pieces together. Nothing is exclusive of another.
Okay. What do you think, Ranjani? What do you advise the budding data scientists? What should they focus on?
Right. I'm a big believer of hiring for attitude and training for. So I think if you come with the mindset that you want to solve the problem and then add value, business value, right? Tangible, measurable business value, then that's the outcome you're after, right? Everything else is a process which will take you to that. So if we start with that mindset, then you will probably be open to learning skills, whether upskilling yourselves on technical skill sets, right? That automatically is going to happen. So I would definitely recommend starting there and then figuring out what is it that will help me to get to that faster, right? That's where I would probably focus my attention.
Kavita?
Yeah, I think to all the budding data scientists, let me first be a bit bring the truth to the forefront. This is not an easy area to be in. This is an area which requires you to be constantly on the learning mode. Even if you have, say, around decade of experience in this space, there is a lot of learning that is required on a continuous basis. So even when you are looking to start out, there is no shortcut that you can take to become a data scientist. I would suggest that if you're really serious to build a career in data science, look at a long-term course which will give you an in-depth understanding of the basic building blocks of data science, be it statistics, be it mathematics, be it problem solving, and of course the aptitude to learn all of these. Now, once you have gone through the detailed course which takes you through all of this, and I would strongly recommend that if it allows you, please do a full-time course which will give you a lot of in-depth understanding all of these. I mean, with the market being all talking about digital, I still feel that full-time course is much more grounded in terms of what it gives you, rather than just online courses. Online courses can be used as building blocks to your existing skill set along the way. So I think that's one bit that I'll tell you. The second bit is you have to do a lot of self-reading yourself, because there is no, again, I mean, there's so much of knowledge and so much of areas of expertise that is there in data science, that a generic overview of what you are doing in your domain is very, very good to have. You appear more knowledgeable, and you are bound to find better solutions if you read a lot. So basically, say if someone is working in a healthcare space or someone is working in a retail space, go and read what the top companies are doing in that domain, because that will give you an idea to look at best practices and try to implement part of the best practices as a project. And that's, I think that's where the difference comes in. A lot of self-reading and grounding of the basics in the first place. I think these are the two basic advices I'll give to budding data scientists. And a lot of hard work along the way. I mean, it's never easy, even after 10, 15 years of experience. And I'm sure everyone on this panel would agree to that.
Yeah, probably I'll add one other thing, Shailendra, right? I hear a lot of people very passionate about, I want to get into data science, right? Reaching out and asking this. So probably they see the glamorous piece of it, right? What they don't see is all the hard work which goes behind it. Like probably 70-60% of our time goes in just figuring out what our data sources are, getting them together, pre-processing them. So if you do get a chance, figure out a way, even within your organizations, to shadow project, actually get your hands dirty, right? I think that's the best way to learn. You can always read and be up to date, but unless you actually work on problems, you don't really understand the complexity behind it, right? And all the sweat and grit which goes behind it. And even post that, if this excites you, then yes, maybe this is the place you want to be, right? So get your hands dirty is what I would recommend.
Yeah. Even like I do agree, like what Kavita and Rajni you mentioned. So basically, there are a lot of forums now to learn. So there is Kaggle, there is a lot of data, and there are a lot of challenges thrown out from the even from the healthcare part. I know there are certain sites or certain like databases which even throw up huge data and put forward a challenge for you. So Kaggle is there, and hackathons. The companies do arrange for hackathons. So whoever has passion, definitely they should go ahead, participate, and have a flavor of it. Have some use cases done and the real projects done, which give you a grip and understanding whether you really want to be in that domain or not. So when you get your hands that dirty, then only you understand what the pain goes into it and whether the feasibility, how much it is possible for that person to take up that domain. So definitely that's a big thing. They should go for it.
I'll reserve my comments on this because I have a video which does talk about this on YouTube, which just talks about what to do when you're trying to get into data science world, and I want to not waste time talking about that, which you can actually see on YouTube. Okay, guys, if you've got a question to these ladies, please put that in the comment section, and I'll take that question for sure. Before I get to the next question, I would like to ask a question to the audience, and this is a question from Ranjani because she said that we should have this question. So, Ranjani, talk about this question.
Yeah, I think I came across this on LinkedIn, on my LinkedIn feed, right, from someone, and I thought it was very relevant, right? Think about any project you might have worked on, any data project, right, any analytics project, and go back and think about the source. How did it start, right? Did it come from your leadership, or did someone come and give you a scope of, okay, this is what we need, or did you actually see a need and you started working on it and went ahead and presented that this is what we should be doing? It'd be interesting to see the answers over here, but yeah, I'd love to hear your thoughts on this.
So, guys, tell us, how did your data science project, if you're a data scientist or if you're an analytics personnel, tell me, how did your data science project start? Was it that someone saw a need, that you saw a need and you started working on it, or your manager requested it, or an executive requested it? How did it all start? So let's have a quick go on it. You can answer it in two ways. One is put the answer in the comment section, or you can open your camera and scan this QR code, and it will take you to a link where you can answer the question as well. So there are two ways of answering this, and I'll keep it here for a minute. But before that, I have a story to talk about. I don't know, everyone would have a story of yours as well, but I used to say this to a lot of people, that my data science projects, I would love to write the RFP for that. And I usually used to do that when I was in Accenture. I used to go in, talk to the guys, understand their problem, and then create the RFP, which only I could deliver. Because this is how I could make it as complicated as I could. So I'm telling you the reality. It's the corporate world does not know the art of possibility, and it is art. Analytics is art, and they do not know the art of possibility. So I would think outside of the box, think what I can do, and would go and say, have you thought about that? And that will give you that much of value. And okay, you define that value, and suddenly you're writing an RFP. And because I have written the RFP, I'll be the one who will be answering that RFP. No one else can answer it, because so I think that's one way of looking at it. And when I was in the corporate world, most of the time I would have found something in the data and would come back to my boss and say, "Have you seen this? We can do this about this." So that was my point of view. Okay, guys, all three of you have been data scientists at some point in time. So share some of the challenges that you've seen in your career being a data scientist. And I'll start with Rupanjali on this.
Yes, Shirin. So, first I would just say like how it started, because after that comes the challenges, right?
Yep.
So, it all started like when I was in my PhD program, and before that I had a flavor of computational biology, all the data and but working on real project actually started in my PhD program when I got the use case, which was more about predicting the vaccine candidate. So, and I had to I had to download a huge database of all proteins, and similarly proteins and genes. So it's huge. So we can understand, right? Even like smallest of the organisms will have millions of proteins and millions of genes, right? So that's when I got exposure to this huge data. And the real challenge for me was like, how do now analyze this huge data, right? I cannot even write like manually. It becomes very difficult because you really have some, after screening, maybe some thousands of proteins which I'm left over to now analyze. So that was one very challenging time for me. Now, how do I do that? But that then pushed me to think about more from the automation and more about like how can I write automated scripts to handle the data. I learned a lot from shell scripting to different ways of like analyzing the data in easy and a faster way. So there are a lot of string matching algorithms in Perl. That time Perl and R were the main things. So that's when I started learning those and kind of automated my process, how I can make sense out of data, which can be much more faster. And then like that was the hands-on piece, and then came the algorithms which we started reading and got a flavor of and it was more of unstructured data, I would say, because proteins, genes, those are more in the form of string. So they are more in the string format which are thrown out to you. So that was the time. It was challenging, but yeah, these challenges give you the platform where if you have passion, you will learn how to do the things in a best way. And in that process, you will learn a lot, and technically you will grow like anything. So challenges help you to come up with better approaches, better solutions, and you learn a lot definitely out of it.
Absolutely. If you haven't had challenges, you're not growing. Okay, Ranjani, your point of view, what kind of challenges have you seen being a data scientist?
Yeah, I agree. First of all, that it is a learning opportunity, right? And for us, we work on problems for ourselves, right? We are not working for a third party. So there is that brings in its own set of challenges because there's humongous amounts of data, right? So our problem is not lack of data, humongous amounts of data. So there are projects where there's real-time topology data which is getting captured, right? And you have all of this GB of data points which is coming across to you, and then you need to kind of figure out and prioritize what is it that you want to do with it, right? Do I want to do like anomaly detection? Do I want to do early warning systems? What is it that I should focus on? And when you have multiple things, I think it's required to prioritize and then say that, okay, this is the problem I'm going to go after, and do I have all of the data sets to kind of go to that? And the second it is you can't consider yourself as only the data scientist. Someone will clean this up for me, give it to me, and then I'll do work and take it from there, right? Gets back to one of the points which the other panelists mentioned, that you need to start looking at the data yourself, manipulating it yourself, bringing it together from various sources, and then understanding the data and then building out what you're doing, right? I think those are the learnings I've had when we kind of started off, right? So teamwork, understanding and being laser focused on what you want to solve is critical learnings which I've got that way. Yeah.
Okay, Kavita.
Yeah, I think for me, I think I'll need to try to talk about two different areas or two different challenges that we generally face on a data science project. And I'll also talk about how can we solve it more efficiently. So the first one is getting the right set of data for your project, because that's where everything starts or everything cuts in. And if you are not equipped to get the right set of data from the stakeholders, or you yourself don't know that what are the data that I'm looking at, or what are the different types of data that is available for me, I think that's very important. And in this sense, sometimes it's very important that some of these projects are top-down driven. Because then what happens, the data people align to you, they share the maximum information with you. Otherwise, if you go with a small template to them or a template to them with the data, they'll just give you what you have asked for them, and you'll not explore the possibilities that would exist beyond what is normal in that project. So I would say the data collection part is the most important part. And I think we need to spend a lot more time. And I have had projects where we have spent around 2 months, 3 months just getting to the right set of data. Because if you are just working with the data which business is anyway working with, you are not trying to unravel something new to the business. So I think that's very important point, that you look at data and try to find out the mysteries within the data also. So you get the first state of data, do some exercise of plotting and looking at the trends in the data, and then go back and ask the data people, why do we see such trends? What can be the reason behind it? And then go back and get more data relevant to it. And that's how a successful project can be built. So one is that I have seen, which is at least at the beginning of the end. I think the second challenge that I would like to mention is towards the end of the project. We are trying to convince the business that this is what you need to do in your business process, or this is the project that you need to implement as a part of your entire business process to see the ROI benefit, or to see benefit in the entire process. And I think that needs a lot of convincing from a data scientist perspective. And trust me, any amount of data science knowledge doesn't help you to do that, because the more you talk about algorithms and the more you talk about what has gone into building the model, the more friction increases, because the business people start thinking, oh, these are all research things or things which don't really work in the real time. So you have to be more and more closer to the business when you talk to them. You have to talk to them in terms of how this will affect your bottom line, how are things changing when you implement this model. So I think those are two different paradigms in a data science project, but very, very important again to get all of this synchronized for a successful project.
And I think that gives a call for people to understand how important communication skills to have a team within the data science team which has a very good communication skills, so that they can talk to the business, talk to the leadership, and explain to them how valuable the work that is being done. Again, comes back to the fact that I can build a model which, or build a project, get a project done which can give you $1 billion, but if it is not executed, what's the worth? What's the value of doing it? And I think you've actually hit it on the head, that we need to have that kind of communication out to the audience, to the business managers, the business leaders who are actually going to execute it, and think that that's my model. And I think that's a good challenge to have. You work in this corporate world where, do you see similar kind of challenges when you go out to your business leaders and try to explain that I found something like this? Can you utilize that?
Yeah, I think we're slightly more mature in that curve. So what? There are a couple of things with respect to that, right? One, in terms of how we structure our teams, I think you put it right. HBR calls it as a data translator or analytics translator, right? So when you're hiring people, hire people with complementary skill sets, hire people who can storytell with data as well, right? Which is very, very crucial, especially when you're like, after you deploy the model, how do you actually explain the value of it, right? The second more pertinent thing is we don't build this in silos. It's not like we take the requirement, go build it, and come back and give that, right? So we work alongside with the teams in building it. So there's no RFP as such, but then what we do is, first of all, sit, collaborate, and come up with, okay, this should be my ML roadmap, have that included in the product roadmap as such, right? And then work along with a SME, for example, as you build this out. Especially we do a lot of NLP, and it's very, very crucial to get SME inputs in spaces like this, right? Especially because text data can be very, very dicey. And so while we work with them, they help us validate it, right? And then they become our champions, because it's not just me talking to the business, it's one of them along with us who's talking to the business saying that this is why it works, right? This is why. And there's the sense of ownership which they carry along with me. So I think that's been a very, very successful model for us, right? It's working out great because we learn, they learn, we all succeed at the end of it.
Well, I'll also add something to it, and that is that I used to, when I was in the corporate world, I used to have 3 roadmaps, and they were in sync with each other. One was the analytics roadmap, which was what are the models that are coming through. The second in sync was the impact on IT, because IT needs to execute it, and if they don't have the infrastructure to actually support an execution, how will that work? And finally, the impact to the customer, the end customer, because I was working and whatever we were doing was impacting the customer himself. So there were 3 roadmaps. And as my ex-boss used to say, I want to know whatever you do, how will that impact the end user in the end? And how do you have that in line? So you're saying that you're building, for example, I'm just making it very simple, a churn model. When will the customer start receiving a churn offer? How is it going to work? So there needs to be 3 different roadmaps that need to work side and side with each other, and they should be in line with each other. Rupanjali, sorry, have you seen something similar, or what kind of things that you've seen?
Yeah, so Chandra, I feel like your data science again is all about storytelling, right?
Yep.
So, and storytelling comes in every piece of it. So, right from when you have the data, then you need to communicate properly what kind of data you want. You need to analyze. Then, when you do the exploration again, you need to come up with a story like what, like from the domain understanding connected. And again, that story has to be there, like what are the features, why you feel it is important with respect to the outcome, right? So there again, that storytelling is very important. Your communication comes in picture. That gives the clients or whoever you are discussing with the confidence that you are able to connect it to the domain, and you are able to tell a story out of it, and why these are important, you are taking these forward in the model, right? Then again, when it comes to the model part, again the storytelling is important, because there are n number of models. Why you feel that these non-linear model is more going to work over here versus the linear models? Why do you feel that is important? Because you see these relationships, right? So you need to defend it again with a conviction and a story out of it. And the final piece, when we give the final outcome to the clients, again comes the piece where you need to explain it. You need to explain from the features which were important, which had the positive or the negative impact, and why. And these are the pieces by which you need a storytelling in each and every piece of it, right from the like data analyst part, where they will be analyzing the data, to the data scientist part, or the end part where you throw it up to the clients. So it's all about storytelling, and if that is done properly, that brings in the conviction, and that brings in the confidence for the clients also when they want to utilize your. So that's how they will be more confident. They don't want anything black box. They want it to be transparent as much as possible, and that gives them the confidence, and even the end user will be confident about using your solution.
Absolutely. And I think that black box approach is long gone. I don't think anyone wants to see a black box where they put in a data and there is something that's coming out without understanding what's going on. Sorry. So, okay, before I get to the next question, I will just put that question back on screen where, we're asking people, what do you think the most meaningful project that you've done? How was that initiated? Was that started by you when you looked at, you saw a need and you started working on it, or your manager requested, or an executive requested it? So all you need to do is either mention it in the comment section or scan this QR code and it'll take you where you can actually answer the question. There are 2 ways of doing it. It's up to you. Okay. Before I get on to the next section, one final question on this section, and that is, why do you see very few women in data science? And I think that's the standard question I ask in each episode, because when I go in and look for women in data science, I find it hard to bring onto the show. We've not done bad. We're 42 women and counting. But why do you think? What's going on? And I'm sorry, before you guys start, I must say, when I was in school, I always thought that girls are more studious than the boys, and that's true. So if that's true, then this is a research area. You should find more girls doing data science than boys. Why is it? Why is there a difference? Why is it that less people are doing it? I will start with Rupanjali this time.
Yeah, Shelders. So the answer is quite like we all know, right? Being women, it's not easy for us. So we are really very sincere in the school times or when the studies. We all know, like if we have a gender comparison, kids, if you see the boys in general, they are much more naughtier, and the girls you will see they are very sincere. They will be mostly studying whatever they participate. They will be very sincere in those things, and that's a trend. Usually we do see that. But when later on half comes, where there are a lot of things which we have to go through, like there is marriage, there are kids, you need to take care of them. Then there are a lot of other things where this gets eventually diluted. So then that what happens, you need that support ideally. So you will see some many a times, like if you have a very supportive family who will support you in your studies, so that's the woman who really will go forward and they will be able to grow their career. So from my experience, I will tell you, frankly speaking, my parents were very keen on my studies piece, definitely. And that's when it got kick-started. I really got opportunity to be part of some of the very good universities during my studies. So I did my master's from Banaras Hindu University, which is one of the premium universities, I would say, in India. And then post that, after marriage, I would say there was a huge support from my husband, which came into, and I when I did my PhD, it was a very tough decision. But the support which he showed me, and that could help me to continue my research and my work. So which I freely could read and spend. I even did my PhD with my small kid. So my kid came after I joined my PhD. So I did my studies along with my kid. So again, like the support which I got from my family was humongous. So that's one thing which is very important for us women, that you get that support, definitely. And you really need support at every, like even good mentors, they are very important in our life. So for me, I was very lucky to have my mentor who was very supportive. Like with the kid, he allowed me to work from home many a time. So I could actually balance between my family and my studies. And even my postdoctorate mentor, she is one of the leading ladies in molecular biology. She's a very famous personality, I would say. She's a student of C.V. Raman. So she is Manju Bansal, ma'am. So kind of, I would say, like these are the kind of people. She was a huge supporter of women again. So she understood what it goes with us when we try to balance between our studies and the family life, right? So we have to get that proper support in each phase of our lives, and those people, when they support us, we get morally boosted, and definitely we can do a lot. And I think everybody should have that mindset of supporting women, and letting them read and learn and go to that research. Data science is very much about research. There are so many new technologies, new papers. It's constantly evolving. So we cannot say what we learned. Maybe I learned 10 years back in my PhD, the same thing goes right now, right? It's not, there's a lot of different new technologies, new research, new papers which are around. We need to be updated with those things. You need to keep on reading. Even now, I think like we all would understand, we all need to spend a lot of time in reading, right? So
Yeah.
it's very important that we have that support, we have that mental peace, so that we can spend time reading, learning stuff, and do our job, right? So that's important.
What do you think, Kavita?
Yeah, so I have a slightly different view on this. I feel that the women in general, and what I have seen is close to data scientists, women data scientists, they don't challenge themselves enough. They try to find a easier path, and that's where some of them drop out, some of them don't get to the leadership positions, and they don't have that self confidence to kind of challenge the voice in the room. And this I'm talking of from my experience. So if you have 20 people sitting in a room, and fortunately if there are two women data scientists in this, these would be the people who would be speaking the least. And I find it very surprising, because the unless and until you make yourself vocal, unless and until you make your voice distinct and people hear to it, there is no way you can find your space through space through an organization. So I think the first point that I want to build is a lot of confidence is required and lot of self challenge is required. Even the point that Rupanjali brought in, like taking care of family, taking care of the other things, I think all of this will go through if you have the belief in yourself that you can do it and you can tide through it. Having said that, in the same journey, I have seen women who have done exceptionally well with all these challenges in place. So it's more of a time management that you do. It's more of that you don't want to drop out your passion. I myself have taken short breaks 3 times in my career for different activities at different points of life, and I've come back. But it is surprising, and I want to quote this figure that 70% of the female engineers that with whom I have studied have dropped out now of the career race. And again, people who did their masters, and I would think when you do masters, you are much more matured and you are very clear on the path that you are taking. Again, most of the female in those have dropped out. So I find it very strange that after you have invested prime of your life studying and working on something just to kind of build your career in this, just with few challenges, you try to drop out of the entire paradigm. And currently, there are so many opportunities where you can look for remote working, you can look for working in at least doing some kind of ad hoc projects where you can keep yourself kind of building up and then get back to the workforce whenever you have the right time. So I feel I would rather challenge the women and say that get up, get there, and you have the potential. Whoever has stood there have shined out. And I'm sure you have examples within Accenture, Shelley, who have kind of risen to the challenges in their own way. So my take is a slightly different. I might have a defense there. I know a strong defense, but yeah, I'm ready to take it. Yeah.
No. One thing I wanted to say before I get to Ranjani about this is you don't let us speak at home. How is it possible that in the office you're not speaking when two women in the room? You don't let us speak at home at all. So what's going on? So I think you need to work on that space. Before I get to Ranjani, guys, this is your opportunity to ask question to these girls. So please put your question in the comment section and I'll definitely take each one of those. And now the question to Ranjani. Ranjani, why do you see less women in data science?
Yeah, so this is a personal area of passion, right? Getting more women into specifically into analytics is something I'm very passionate about. I have been raised by two working parents, right? My mother worked more than 3 decades ago. So for me, that is the normal, right? I don't see that as any different for me. So I think it boils down to 3 key things, right? First of all, starting with what Kavita said, right? Having that confidence in yourself. So I have a 5-year-old daughter and I love my job, right? I love having a career. So my narrative to her is not that I'm working because I should be working. I work because I love working, and that's part of my identity as much as it is my identity to become a mom, right? To be a mom. I think that's what I want her to grow up with, right? So having that confidence, it's a choice, right? Some people may take a choice not to do so, which is fine. But if you do take a choice that you will work, you're not, I think suffering from that guilt is something which we should totally put out of the window, right? You can be a good mom, you can be a good career person. It's not two mutually exclusive things at the end of the day. The second thing is the support system. Definitely, right? It's very easy to say. I got back to work 4 months after my maternity leave. I've never taken a break. And it's easy to do that because I had a solid family support, right? So I think that's also does play a role to an extent. And most importantly, the organizations, right? The support you get from your organizations. Been very, very lucky that way to be part of organizations who actually walk the talk in terms of that, right? And that plays a big role, especially in terms of standing up and owning the room and talking out your point without fear of being reprimanded, right? And it's not just a checkbox item. I think many organizations are waking up to the fact that you focus on diversity beyond just being a checkbox and having that end-to-end across how we attract talent, hire, retain, and upskill our workforce, right? And we need to have this constant conversations. It's not just like once in a while thing, right? We need to have conversations, help mentor, upskill women, and provide a platform as such. So I think it is an ongoing journey. It takes all of this and more to make this happen. And it's not specific to data science, right? I think McKinsey released this report on Lean In, where they call this as a broken ladder. So what they say is there's like you rightly pointed out, many women top their schools and colleges, they get into workforce. Where do they drop out, right? They drop out at that first step from the entry level to a managerial role. And that's a huge obstacle, which is keeping women from advancing in their careers. So if you do believe, first of all, believe in yourself, like Kavita said, if you want to, go out and get that, right? And I hope more and more organizations play their part in making this happen. Diversity of, and clearly a topic I'm very passionate about. Just going to close with this, right? Diversity is not just a right thing to do, it's also a business value to do, right? It's been proven through research that having diverse teams absolutely makes you better as an organization and as a team and adds value to your business. So definitely something which we should be doing as well, beyond just being the right thing to do.
Okay. Before I get to the next topic, guys, any questions in the comment section? We'll take that just after this section now. And also, please like and share this particular video so more and more people can learn from these passionate women in data science who've been doing that for last, collectively, how many years we've got here on the table? 15, 13, 12, around about 40 plus, and I will add mine, which is 25 plus. So
You're making us sound very old, Shaili, but okay.
yeah. When you were born, I was still doing analytics. So that's where we are. Anyways, so please ask your questions and also like and share this particular video. Let's talk about success stories. I firmly believe that success stories play a major role in promoting a particular stream. And I say that in almost every episode of mine, that if it was not for Nappy and Bear story, data mining would not have been popular. I don't know whether you guys remember that, and I used to talk about this long time ago, that, people started talking about people who bought nappies, also bought beer, and that was an association that was found in somewhere in Australia only. So that was one of the analysis that we always used to talk about. Then how did you actually figure that out? So association analysis was very popular in those days, and that drove people towards data mining. So if you've got a story that you've heard or you were part of, and you want to share with the audience, then this is your time, guys. Please, if you want to share, if it is someone else's story, you want to take the name, fine enough. You don't want to take the name, fine enough. And also talk about the benefits that people actually got from that, so that people can understand the value data science brings in. Even if it is saving one life, I'm up for it. So guys, who will start? Kavita, this time.
Yeah. So I think I have a very interesting story on the success of a particular model that we were building. And this model was in the fraud space. So we were working with a digital payment company. And this digital payment company was trying to figure out what are the reason for fraud losses, because that was the time, and I'm talking about a project which we did some 3 to 4 years back, and that was the time digital payments had just started, and they were losing a lot of money on fraud. And remember, whenever we talk of digital payments, the transaction amount at one go is not very large. But if you accumulate the entire number of transactions over a day, over a week, or over a month, that is huge. So we were trying to solve this problem, and we were trying to figure out. And as any other financial company, they already had fraud systems in place. So no company starts doing its work without having a fraud system in place. So we started doing a lot of research. We started looking at the data. We started looking at different originations of transactions. So either it was customer begin transactions, or it was agent driven transactions. And after some analysis, we tried to see that we found that agent side, the transactions which are driven by agents are having more fraud as compared to the normal customer driven transaction. So that ignited in our mind the idea that, yeah, there is something to do with group behavior or herd behavior, which is driving this fraud transaction. So it's not just the geography or just the type of agent that we are talking about, but there is something to do with the group behavior, and we need to solve this problem. So we started doing a lot of research. As Rupanjali is always mentioning, the data science is all about research and doing more and more of it. We started doing a research, and we decided that we will do a social network graph for these transactions. And we will do it for a period of, say, 1 month, 2 months, and see if there is any kind of group behavior that we can find out. And that was the first time we started using a social network analytics graph. So SAS used to provide it, and then now Python, R, everyone has features where you can build a social network graph. And very surprisingly, we found that people who were connected to the same agents, or we were working in the same organizations, because when you build a social network graph, you need nodes which will have common boundaries, like common endpoints. So we saw that people who were working in the same organization, so just on a T, okay, how did you kind of do this? I mean, do this transaction, or okay, I use this particular agent for it. So they found a lot of common behavior. So we found that something which was almost in research those days, social network analytics, we could bring it to the table, do it within our own real-time data, and use it to find more and more fraudster. And the good part was that this was not something which was done post the transaction. We could preempt that, okay, this is the person who has got connected to this agent, and now there is a chance that the fraud can be prevented. So this for me was a big success story, because we started to do something apart from all the machine learning algorithms, apart from all the rule-based framework that we were already using in fraud. We decided that we will take a step further and look at the social network graph. And now with the advent of so much of social media and people forming groups at different platforms, it has become more and more powerful, because you have so many common platforms to kind of find those linkages and connect the right dots. So for me, this was an amazing success story in terms of use of a new technology in the area of fraud detection.
And you've touched the nerve here, because I love social network graphs, because we actually figured out how insurance fraud happens when a car which is damaged goes to the same repairer, which he's far-flung repairer, doesn't know where he is. And when you build a social network graph, you find out that everyone is going to him because of an agent who's telling them to go there. So that let's not go there. What was the kind of value that was to the organization in ballpark numbers? Was it huge?
So I remember that from so I don't remember the exact value numbers, but I remember that at that time we were able to detect at least double the frauds at what we were detecting at that time. So we were able to detect some good number of frauds at that time, and we could almost double it. And remember, every fraud that you can stop is actually almost the value that you are saving for the organization. So if I am correct, it ranged something in the range of 8 to 10 million at that point of time, which was a huge number for the organization at that juncture.
Okay, good stuff. Ranjani, your turn.
Sure, yeah. So first of all, my team structure, right, is how we can drive business value and customer experience with data, right? So we kind of work on multiple projects at the same time. And there are two types of things we do, right? We work on machine learning that can help drive decision making, and we also do ML, which gets integrated into proactive support products, right? Basically, like products which can help identify issues before they happen. So the way you approach it is slightly different. So maybe I'll talk about the story, maybe hoping that people take away learnings from it, right? So like earlier, we work on huge amounts of text data, right? We leverage NLP. We've kind of done unsupervised models, semi-supervised models. We've done LDA, word to vec, BERT, etc. Right? And I think one thing we have realized which works is, like I was saying, only kind of co-build these ML solutions with the SMEs did it actually turn out to be valuable. For example, even keywords like consolidation, for example, right? How we use it in English is very different from how a technical issue is. So that cross collaboration kind of helped us in putting together a solution which actually works. And this problem, if you think about it, right, in customer experience is foundational. Only if you understand what are the issues that customers are raising, can you come up with different ways in which you can solve them. So that I would therefore consider a huge success story, right? And another key aspect to this is we pay a lot of attention to the production of AI. We don't pay as much attention to the consumption of AI, right? How will stakeholders or the business consume this information? So we kind of built out the suite of ML web applications based on Django as a consumption layer, right? Because it allows us to provide close-loop feedback from the users as well, and constantly have a self-learning system. So kind of now we have the suite of solutions which allows us to provide recommendations around what is the right content which needs to be surfaced, right? So that customers can self-serve. Can you provide early warning systems to predict escalations before they happen, so on and so forth. And the second piece, like I was saying, is models which can get integrated into products, in which case there's definitely a process change required, right? For example, if you're predicting what's the severity which an issue should have, even when the customer is entering the issue, right? That's going to help route that issue to the right technical expert and therefore solve the issues faster. So those kind of things kind of help a lot. And it is required to work with teams over there, because finally this may get integrated into Salesforce. So yeah, I think that's what I would want to conclude with, right? Kind of bring together all of the key players in order to see success.
So have you guys thought of sequence of events? So there are 2-3 things which are very, very close to my heart. One is social network graph, and the second is sequence of events. Because you've got that kind of IoT data, in other words, because you've got a lot of machine data as well, do you also see what causes a failure to a particular process and what leads to that? So for example, process A, B, C, if the process A falls to a certain threshold level, the chances are that the process C will fail. Do you look at that as well? Don't get me wrong, you may have done that, or you may be doing it. If you're not, think about that. I'll move on to Rupanjali.
Yeah,
Rupanjali,
what you said, like on the network side, it's really interesting. I just recalled one problem statement which I worked long back in my master's. So even this theory comes in picture for proteins as well. So you have some nodes which are highly connected, like atoms which are highly connected to the other atoms, and if you hit that node, your protein gets dismantled, the protein gets destroyed. So if you can hit that point, that's the highly connected node. So this was one very interesting case where long back we worked on to identify these nodes which are the highly connected nodes, and so that we can disrupt those specifically for pathogenic proteins. And then what happens, the pathogens usually, if you hit those proteins and can destroy them, the pathogen itself gets destroyed, right? So it's a very interesting concept which can be brought together everywhere. Like you talked about social media, it can also be part of your life sciences and healthcare as well, right? So quite interesting.
Okay, so any use case that you want to share?
Yeah, so, okay. Throughout my career, I would say I have really worked on a lot of problems and lot of data. So earlier, like I was mentioning, when I was purely into bioinformatics, I had worked on proteins, I had worked on genes, and then in the core healthcare domain, I have worked on your sensors data. So in the ICU setup, you will see there is, when the patient is in ICU bed, there are a lot of sensors connected to his body. Right, so the ECG comes on in that screen. You will see the ECG picture which comes on. You have the heart rate which comes on. So you have the oxygen. There is a SpO2. Usually, you will get a sensor which gets connected to your finger, index finger, and it captures the oxygen level in your blood. Right. So I worked on these kind of your medical signals. So signals is again a very different aspect, like ECG, SpO2, heart rate, and lot of the signals which we try to capture from the patient. Then there's medical imaging, where you can do some prediction whether the image is like anything. It can be TB or non-TB, or maybe any like COVID or non-COVID. So there are a lot of imaging use cases as well, right? And even like healthcare also gives you a facility where you can look at the financial part. Like you have a lot of health insurance claims and others which we usually file. So there's a lot of aspects to the healthcare, and being part of this domain of life sciences and healthcare, I had this opportunity to work on these diverse kind of use cases, right from imaging to signals to proteins to genes to financial. So it's a lot which was there. And more or less, like many of the projects which were client projects, and which we could convert into a solution which could provide, I would say that gives a huge sense of achievement, because those are real life use cases where we are trying to help out our patients, right? So we are really making an impact. We are making an impact where we can save their lives. So that is an immense, like from the success point of view, I would say many of my projects which I've done is a huge level of accomplishment associated with that. But saying that, I would focus on one of the projects which was my first project in my career, which I had done and which gave me an immense exposure. So that was my PhD project, which was given by my guide like Srinivasan Ramachandran, IJAB. So I would briefly, like very quickly, talk about that project specifically. So that project was more about like we had to predict the vaccine candidates. So given a set of proteins from a pathogen, we needed to predict which of them are are adhesins and non-adhesins. So adhesins are actually the proteins by which these pathogens they come and attach to our body. So they have certain proteins by which they attach to our body, and then only the transition or they get into our body basically. So those are the attachment proteins. So idea was like if we can hit or if we can actually block that attachment protein at a very first place, we won't allow the pathogen to get inside our body and the infection won't happen, right? So that was actually the use case which we had to work on, which I was given actually. And what we usually do that these are all predictions, right? So what happens in labs, you have a lot of testing which goes on. So they need to amplify those proteins, they need to push that proteins in mouse. You have seen like white mouses, and they do experiment and see whether actually what you have predicted, whether actually that protein is a vaccine or not, that is feasible to a vaccine or not. But when they are blindly doing, they have millions of proteins to work on. They don't know like which one to target. So when we can give them a screen, we can give them a set of proteins that, okay, you focus on only these thousands, or maybe you focus on only these 100, actually I should say a smaller number, which you can focus, then you are saving their time. They don't have to experiment with all the random experiments and what they think can be the vaccine candidate. And they don't have to do that because you have pinpointed and you have said that these are the high probability ones which you should focus, and you should test them on the amplifier and test them on the mouse. And you actually save a lot of their time and money, because there's a lot of money which goes into for those cultures, for those organisms on which they are tested and all, right? So actually, so that was the use case. And so this was one thing which was really good for me. Like I could actually, I was exposed to a lot of proteins which I had to screen, so a lot of data. And then the prediction algorithm or the model which I developed, another thing which a very important thing is like in that times itself, I did deploy it on a server. So I have a complete web server on which I have created a web server where you can submit the protein of interest, or you can submit the entire list of proteins which you have. And that model runs at the back end and you will get the real-time prediction. So going with this entire integration, right from like getting your hands dirty with the data mining part to applying the algorithm, then deploying the algorithm on a web server based environment and creating that entire interface itself. So all the pieces, like PhD takes time, right? So it took 5.5 years for me, but this exposure was a great thing because I did the end-to-end solution, right from getting the data to deploying a model in a real scenario and where people can use that. So this was converted as a publication, and I'm really proud to say it has a huge number of citations. People are even using it right now also. So it's it's an open source solution which is available, and it is in a way helping people, and it's a live solution where end-to-end from the model is itself deployed, and that gives me a lot of learning throughout the process, which I could actually leverage during my next go on whatever projects have been done. So I'm actually now confident that whatever, after that use case, it was like I was confident that whatever is given to me, I can do it because I have done every piece of it. So I know the pain of it. So that's something.
Before I get to the audience Q&A, one question which I ask all the time, because we're going through this pandemic and data science is more art, less science in my view, I would ask you one question, and you can think about it in a way that whether that is real or not, you could think outside of the box. Can data science help in solving COVID-19 in any way or form? You can use your healthcare experience, Rupanjali. You should use your VMware experience, Ranjani, and You should use your consulting experience and think outside of the box and see where can data science help the team. Who wants to go first? It's an obvious to ask Rupanjali, and so I'll ask you.
Yeah, Chandra. So this is quite eminent, and the answer is we all know, right? So it has to be there, right? So what we have seen, like earlier, the demand for AI solutions in the healthcare was there definitely. We all know it is a very upcoming field. But now, after this pandemic solution, we do see there's a huge people do understand like where AI comes in picture now in healthcare and why it is so important now to have some of the AI solutions which can help. And especially nowadays, people are not even going to the hospital. They want some of the tele solutions, right, where you can communicate from the home and you can actually just tell out what happened, and the clinician can help you out. So now the thing is like it's much more live in action, which we see, and healthcare providers they were able to identify that what's the importance of having these solutions, and they're really going for it. So there's a huge demand now, and they know like where right from like the tele solution to coming up with some predictions and even there are scenarios like in COVID, what happened, we all know, right, the devices and all, there's a huge demand of these ventilators or some of the oxygen cylinders, and the devices need to be ready. So there are a lot of things which are from the operations part which we can think of, like how can you think of the preparedness of what are the, even from the operations part where we talk about the devices or we talk about the workforce like nurses and doctors, how much what are the numbers which they should be available for to cater this huge volume of patients, right? So there are a lot of things which are coming into picture which people may not have thought of earlier, and now we have all these parts like operations, the clinical part, and the financial part. Maybe I can leave it aside for now, but definitely the operations and the clinical part, we do see a huge demand nowadays, and they are helping in some of the other ways for solving this COVID situation, handling this problem in much more efficient way, I would say.
Okay, Ranjani?
Yeah, first of all, technology in itself, right, is going to play such a pivotal role in this post-COVID world, right? Imagine that it's been, 6 months, 7 months since I've been working from home. Imagine the scenario earlier, in the earlier pandemic. So I think that technology in itself is a great leveler, right? And AI in specific, I think it's going to be in the forefront across sectors, especially in healthcare and education, which has become so critical right now, around telemedicine, around providing personalized recommendations, right? I know there's so much of work happening on the automated image diagnostics space, bringing in virtual assistants, chatbots, for example. Also around workforce solutions, right? Future of work in itself is going to be very, very different from, it's not like it's going to go back to normal, right? It's going to go back to an office and workforce, which is very different from the way we left it. So how can AI help with social distancing? Can it check for whether a person is wearing masks? Facial recognition systems could be powered by AI. So I think from the future work perspective, this pandemic kind of accelerated all of our efforts on digital transformation, and many developing economies itself can take advantage of this scenario, right? So definitely huge disruptive impact is what I expect for AI to play in this post-COVID world.
Okay, Kavita?
Yeah, I think data science has played a very, very important and urgent role, I would say, in this pandemic. And this is very close to me because I know one of my friends has worked on this. So this friend of mine who is a professor from JNCSR, which is a very renowned research institute in India, he had developed models. At the first stage, he built models to predict the rise of COVID across states. And then he was in touch with the PMO of India, and they asked him to build district level models to see how will the COVID affect and how will the COVID rise peak during next 2 months, 3 months. And this model played a very, very important role in getting the states and the center ready for the pandemic. So I think the first very important play was there. I think the second important play, and this is again one of the companies which I was doing ad hoc consulting, it's called Cognitrix, and they have developed AI-based solutions which can help recognize people with masks and without masks, similar to what Ranjani was talking. So they have their platform, and it's all over LinkedIn that they have advertised about it, that they can build a lot of AI and IoT based solutions to fight this pandemic in the future world. In fact, the same company is also working with the airport authority globally, see how we can facilitate more and more safe flying for the passengers and the airport staff in the post-pandemic world, which is like still imagination away for most of us. So that's the second part where it is playing the role. The third part, which I think I would briefly like to touch across, is my company in Finance Modeling has been doing a lot of forecast on the impact, economic and financial impact, which unfortunately is going to be more long lasting than the physical and the medical impact that we have seen. So I think all these three aspects have very tightly ingrained data science solutions into it, and I hope data science helps the world fight through this pandemic in a more positive way than we have been doing in the past.
Okay, that's great. And I think there are other things that I've seen as well, that they were able to predict the wetness, the wet lungs of people utilizing the data upfront to see if you're more susceptible to getting COVID-19 or not. And there are other things that are happening. So there are quite a few things that are happening with data science. One question before I get to the audience Q&A. First one request and then the question. The request to you guys is, as I said to you, that I'm finding very difficult to find the women in data science. If you could recommend 3 women in data science each, put that in the comment section. I'll reach out to them and put them here and try to put them and I'll try and understand their point of view. So if you could do that, that'll be great. So I'm just trying to do 3 into 3, so it becomes 9, and then I can get 9 people, and then multiply by 3, we'll get 27 people, and so forth. So please, I request you to kindly mention 3 people who you think should be here on the show. Any of your mentors, any of your leaders, any of your peers who you think can share their stories. I've got some wonderful stories to share. Please do that. And a final question to you from me before I get to audience Q&A. How do you envisage data science to progress in the next 5 years? Let's talk 5 years only, because we don't know where we're going to go after 5 years. Let's start with 5 years. So where do you think it's all going to pan out? Ranjani.
Right. I think in terms of the maturity curve, right, I would think that that's going to increase. Organizations are going to go up the maturity curve, have AI integrated as part of their business teams, for example, right, without actually looking at AI as an afterthought. I think that's definitely going to happen. And we already see that, like within organizations like us, right, we already have integrated as one of our product roadmaps. So for example, how can you build a customer experience solution in the front end, which integrates AI within it, right? Not necessarily just collecting the data and then do analysis and come back with the decisions. So that's definitely going to increase across organizations. And from the forefront of technologies, I think one key thing which I was reading about, maybe something I want to point out, is you might have heard of this futurist called Peter Diamandis, right? So he talks a lot about converging technologies. I think that's definitely scale, right? So we talk about how technology has been exponentially increasing, but beyond Moore's law, I think the bringing together of multiple technologies. You mentioned IoT, so how AI can come in along with 3D printing, along with different technologies coming together and converging is going to massively scale things, right? And with the impact of 5G coming in as well. So that's going to build a future which is very unlike what we see. And this is not very far away, right? Even 5 years, 10 years down the line. Once we have the advent of 5G, you can imagine the number of people who will get opportunities to look something. Data and the amount of data which is going to get collected. So it's going to accelerate the level of progress which we can play. And last, again, which is something very passionate about, is how we can work towards building the safe AI, right? Or what people call the ethics around AI, to build a future which we want to be in, right? Because people talk of AI as someone else is doing it and as machines which will come over and take humans, right? But research has actually proven that the number of jobs which AI can create is much more than what people will lose, right? So I think the future is up to us in terms of how we want to build it. And everyone should kind of look towards upskilling themselves, right? That's been the narrative across this. How can you continuously upskill yourself, provide value to yourself and to the society?
Hey, what do you think, Rupanjali? Where are we going to go in 5 years' time?
Right. So right now, what we see, like there is a huge, I would say, a much better computational power, which is now coming in picture eventually. Right. So whatever computational powers in terms of you have like the high-end GPU cards for your deep learning experiments, and the computational power which now is enabling us to handle huge amount of data and run very exhaustive computational algorithms as well, right? So computational power is growing a lot, and we also see that your cloud solutions, right? So which was this cloud coming in picture is helping all of us, like the companies, they don't have to invest in some hardcore like hardware solutions. They can think of these cloud solutions to bring up a lot more enablement, right? So these are the things with which I feel that maybe going forward, what we are seeing, or we are already in healthcare. Definitely, I would say we are already seeing the transition that wherever you see that huge amount of data is there, so people are going to leverage these your computational and cloud solutions, and these will enable people to come up with more AI solutions, and where they will leverage this data, and maybe those will be part of the existing solutions. For example, the devices which we see in the ICU setup and the healthcare, like we have so many ventilators and all these devices. Maybe we will have going forward some of the algorithms which will be part of these devices itself in some form or the other, which can capture the census data and can give some predictions around. And similarly, like wherein we are like here also, we have a lot of data. So wherever like data is there, you will see this transition happening where people will come up with certain AI solutions, and we will add value to the existing solutions which we have already, but those will be like more of AI and ML solutions which can be open to the end user, and they will definitely get value out of it. So 5 years down the line, definitely we'll see more of AI integration in most of the solutions. Wherever like companies have data, they will try to make the best out of it.
So, in other words, you're saying that the normal processes will start getting smarter as we go
Yeah,
forward.
exactly.
Okay, Kavita, your point of view? Where are we
Yeah,
going
I
to
think
go in 5 years' time?
according to me, one of the things that will be heard a lot in the next 5 years is blockchains. I think blockchains is still to kind of live to its potential. But having said that, I think across industries, what we have seen is that blockchain has got a huge application, be it financial industry, be it ledger industry, be it agriculture industry, be it in the area of international trade. I think data science will see a lot of application of blockchains being fed through the processes and implemented in the process, entire process, because that will ensure a lot of transparency, lot of legitimacy, and a lot of, I would say, democratization of the data itself. So I think blockchain is something which is going to be a very important phenomena in the next few years. I think the second bit, which I think Ranjani did touch upon, is the IoT. I think we are going to see a lot of real-time analytics being done through the IoT data. Earlier, the kind of technological platforms that we have didn't help us to do a lot of data analysis in real time. But now, in the last 2 and 3 years, we have grown so much on the technological side itself that now, with more and more companies adopting IoTs, I think it's time to get real time on most of these IoT devices and use of this data. And of course, healthcare is going to be a big beneficial of these IoT embedded techniques and revolutions that is going to drive the industry. So I think these are the two major areas that I would want to talk about, apart from what my co-speakers have added.
Okay, so blockchain and IoT processes are getting smarter as we go forward. Great stuff. Okay, let's get to the audience questions. So, guys, audience, this is your chance, your last chance to ask questions to these ladies. If you've got a question, put that in the comment section, and I'm going to take it now. Let's start with the questions and comments from the audience. Very quickly, go start. I'll try and take as many questions as I can. Okay, the first comment is from Ari Shekhar. He says, "Hi Shailendra, hi Ari Shekhar, how are you?" He's saying, I hope you're well. Yes, we're well. Aditya Garg says that his company is doing more of ad hoc analytics services. Okay. Amit Pranjpe says, hi Amit, how are you? He says that they're doing more of data management at the moment. Vikas says, hi Vikas, how are you? He says that they're doing more ad hoc analytics. It's very ad hoc. Okay. A real question from Vikas. He says, I'm working biotech domain as data scientist. Currently, I'm doing analysis of different genomics data sets from labs. Interesting. Rupanjali, do you want to add something to what he's doing? Anything you want to help? You want to say?
Yeah, so as I heard, like he's doing more on the your labs, the genes data is analyzing, right? So that's a very interesting and a very, I would say, in bioinformatics, it's a very common, like you usually have this use case which comes in picture, and it really is a very value add problem or a use case which people do work on. So you can actually look at this genes data. These are more from the, I would say, you have the string format, right? So you can think of more of the NLP solutions over here, which you can think of leveraging. So bigrams, trigrams, and those, like you can do the frequencies and you can come up with some of the algorithms. And again, since you will end up with huge number of features, I'm expecting, so definitely you can look for some of the algorithms which can handle these huge number of features and some of the non-linear kernel methodologies which can come into picture. So definitely it's a very interesting use case, and you can leverage more of NLP kind of solutions over here.
Okay, perfect. Prapul Palli says hi. He's regular on the show. Hi, Prapul. How are you? Aditya Garg says that he thinks data scientists are problem solvers. Fair enough. Yeah, that's a good to look at. Okay, Raghav HR. Hi, Raghav. How are you? On LinkedIn, he says, what are the courses for beginners in data science for CS engineering girls to start their career in AI data science? Who wants to go for it? Kavita?
There's no
Yeah.
lack.
Yeah, please go ahead, Ranjani.
No, I was just about to say that there's no lack of courses as such, right? There's just so many MOOCs available right now. So it's about picking the area which is of interest, right? Maybe if they are, maybe start with the tool. Like if they're interested in Python, maybe pick up a course which would allow you to play around with the sets. Yeah, go ahead, Kavita. You are saying something.
Yeah. I think there are around quite a few courses currently on the correspondence level also. So I would say that there are courses which IIT and AMS are driving in the data science space, and they span from 6 months to 1 year. And some of them allow you to do it with a combination of hybrid classroom lectures plus online video recorded lectures. So those are a good place to start with. Apart from that, if you are just a computer science engineering girl, which is a specific question, I would say that please go ahead and join your 3 years master's program in data science or statistics or economics, because that will help you go a long way in the data science field. I think all of us who started some 10 years or 15 years back had just the masters with us, which was not even like data science as we used to call it at that time. We just studied statistics in a lot more detail, econometrics, and that's what has worked as a foundation stone for us. So if you are just a computer science graduate, I would suggest go for a full-time 2-year master's program, either in India or abroad if you are getting an opportunity, and that will help you build a good career in data science. And if you are looking at something to do with while you are working, then of course you can look at some of the good platforms. And I have heard a lot about the course that Stanford drives for data science. That's a very well-paced course, and a course which comes with a lot of live projects, etc. So I think that would be very helpful for people who are beginning in that area.
Rupanjali, you want to add something?
Yeah, definitely. I think Kavita covered most of the things. So if you have time, definitely go for a full-fledged course, because that gives you more grip on the subject, right? So you will spend more time in a full course will help you be more, learning will be much more than you take up these Coursera or the Udemy courses. These are small-term courses, some hours you will be spending. But if you really want a grip of it, you should go for the full-time courses. Other than that, like if you don't have time, definitely your Coursera, Stanford, that is really wonderful. Some of the courses from the Andrew NG, this quite famous, we all know. So with concepts at a very, I would say, basic level has been captured. At the same time, it's not so deep that technically you won't be able to understand. So it's a mix, and that's a good place to start with. So you can actually go for these courses for maybe specific to some of the domains if you're interested. Then deep learning also. So they have different domains catering to these courses as well. So that can be something. If you don't have time, you can go for that option as well.
Okay. My personal point of view on that is two things. One, Harvard has a free course that they run in data science and machine learning. It's absolutely free. I actually someone said it to me and I just went into register. Now they keep bugging me, but that's a different story because I have not attended anything. But there is a Harvard course that is absolutely free. If you want a link, please reach out to me. I'll send you the link to the courses. There are lots of free Harvard courses at the moment that they were doing during the pandemic, so that people could learn for free. And then you could get a certificate also. You'd become Harvard intern in no time. So that's one thing. But the second thing, which is important, which I suggest to almost everyone, and if you're a computer engineer, then even more, is that go and read your 10th class statistics book. That is the most important thing that you need to do if you want to get into data science. Because all those people who want to become data scientists are the ones who actually left that chapter of statistics at that time. So go in, pick that book, start reading from statistics year 10, 11, 12. As you go forward, you will create your foundation. Once you have the foundation, any course is easy. Otherwise, you will struggle even delivering those or getting understanding of those courses as well. So please, NCN. If you're in India, NCRT year 10 is the best place to start. And if you live in Delhi, I can tell you go to Naisarak and you can get the book too. Anyway, that's a different story. Okay, let's move on to the next question. It's from Amir Gorai. Hi, Amir, how are you? And he says, how data science is helpful towards invention of vaccine for COVID-19? Anyone wants to have a go?
Yeah, maybe we do see this one as it's a very good question actually. So how does data science is helpful towards invention of vaccine? So it's again like the same concept which I talked about, right, in the very first place. When you have a huge set of proteins and you want to streamline to some of the vaccine candidates, definitely you can do that. So when I did my PhD program, that was the key solution. I was working on a vaccine candidate for a different pathogen. So here the COVID-19 situation, you can think of this as the pathogen, and the proteins are actually the vaccine candidates which can be targeted. So this again comes like definitely it is a feasible use case, and you need to just have the proper training set available, which are the positive and negative sets again, and which are the likely vaccine candidates you want to focus. Once you have a proper training set and you try to streamline and do a good algorithm around it, which can streamline and give you high set of a probability number, which set of proteins which are likely to be vaccine candidates, then it can be taken forward to the lab testing and other things, right? So I see a lot of work already started on this. Even the paper which I had worked, that has few citations around people using it for the COVID-19 work as well. So it's feasible, definitely.
Good stuff. Now, quickly move on to the next question, considering the time. Amit Paranjpe says, hi Amit, first of all, how are you? He says, do anyone think stuff like data science should be actually taught in school curriculum? What do you think, guys?
Yeah, I think there's a lot of thought around it, and some of the curriculum have already started giving as an elective, data science as an elective for 11, 12 student. And I think it makes a lot of sense because the world is going towards a place where every domain, every field of work that you will be in would require some knowledge of data science. So I think having it as an elective in class 11, 12 to just people get a feel, and even also people who want to make their career have an idea of where it is, what it is, and where should you look at if you are going to become a data scientist. So I think a good idea. I would advocate that.
I think people should first make sure that they start studying statistics in their school, and make sure they don't skip that, because most of the time people try and miss that particular chapter. Rest is good. Ranjani, do you have a point of view on that, or should I move on?
Yeah, as in kind of reiterate what Kavita said, right? The basics right, I think, is what is important beyond just picking up on data science skills. If you get your math skills right, I think data science is automatically follows, right? I agree to the point that it could be part of the curriculum, right? And this is something which they would end up using. So it makes sense to have that as part of the curriculum.
Okay. Next question is from Avinish Chandra. Hi, Avinish. And Avinish is, he's saying, it's an extremely big challenge to connect the technical side with the business side. There is a bridge of business and analysts which does so, but most important part is how you structure the teams. Totally agree with that. Anyone wants to have a comment on that, guys?
I think, Shannon, we have already taken it up, right? So it's kind of you should have structured teams where which can cater to the data. If you have huge data, you should have the capability to host the data and have it in a format from where the data can be extracted and can be hosted. Data has to be hosted somewhere, right? Then comes the second piece where you have the data analysts and the data scientists who will do the extraction, who will analyze the data, who will come up with the algorithms. And the third piece is like where you have the again some where you don't need to host the solution finally for the clients, right? And what they exactly want, you need to have a interface where they get value out of it. So it's again the same story. Like it should be in a structured format where the things are people. These teams need to work together to come up with the broader picture of the broader solution.
Okay. Next question very quickly. Our next comment is from Dushyant K. Tyagi. Hi Dushyant, how are you? Dushyant was on my show a few weeks ago, and he's advisor to the PMO in India on agriculture and AI and agriculture kind of areas. So hi Dushyant, how are you? There is a message from Prince Kuram. Hi Prince, how are you? And he says, every person in the world has its own share of responsibilities. Data science is the new era in IT, and we expect a lot of innovation that are yet to come. It's evolving beyond our expectations. The good thing is, these days, all over the world, women are taking interest in data science and in software development. Okay, that's good. Thank you. And finally, he says, in the future, I believe Google Cloud, Amazon, and others will take over data science and provide services and solutions to the company. Comment. Anyone else wants to add to this? Kavita?
Yeah, I do guess that there is a lot of technology and data science merger that is helping the world set on the path of, I would say, a AI or a machine learning revolution. And of course, the people with a lot of technological bent of mind are going to help us a lot in doing newer and newer stuff in the data science space. So I do agree to the point of view that Prince Kuram has shared.
Okay. Anyone else wants to say anything? Good stuff. Okay, so that's it, guys. Before you go, one question to all of you, one comment from all of you, a phrase that you want to leave with the audience, anything you want to leave for the audience, this is your time, a phrase or a line, something short. This is your time.
Yeah, so for me, I would say it's not a phrase, but I would say that in data science, I believe strongly like you should stick to a particular domain. So that helps you to become a SME in that domain, and that will give you. For me, I feel that for healthcare, I am very passionate about this domain specifically, and my interests around. I would work in any of these the operations or the I would say financial or the clinical. So, but it would be around healthcare because that would make me SME going forward, and I would have that passion. I have the passion for healthcare. So if you really want to go in this data science domain and be a leader somewhere, it's kind of you can focus on one domain wherever you feel you have a passion and go with it, and definitely you will achieve a lot.
So in a way, you can say follow the passion.
Yeah, follow the passion.
Okay, Ranjani.
Yeah, so I would probably say average is over. It's also a title of the book, by the way, right? So mediocrity doesn't sell, right? And I think going into the future, especially with all the technological advancements and converging technologies, like I said, there's no longer any differentiation which you bring in as a human unless you are exceptional, right? So keep learning, keep bettering yourself. It's not a competition with others, it's a competition with yourself. So keep bettering yourself and remember that average is over, right? Yeah. So that's what I'd probably leave it.
Good one. Kavita?
Yeah, I would add that data science is the sexiest job of the century, but with 3 to 4 hours of learning every day that you have to put into it to stay alive and make it happen. So yeah, I'll kind of end with that.
Good stuff. Okay, guys, thank you very much. Thank you for your time. Like every time, I promise myself to be within 1 hour, but it always goes beyond 2 hours because there is so much to talk and so much to discuss. And with so much of passion coming from the women in data science on this episode, we always lose track of time and we keep on talking. So thank you very much. It was a pleasure having you on the show, all of you, and I'll speak to you soon.
Absolutely. Thanks for having us.
It was a pleasure being here. Thank you.
Thanks.
Thank you.
Bye. Okay, guys. So these were the three beautiful ladies of data science. I hope you learned a thing or two from these ladies. Thank you very much for attending the show. Before we go, I must say, I must show you those three questions that we had. The first question was, what do you think is the level of analytics sophistication of your organization, whether it is data integration, descriptive analytics, ad hoc analytics, or predictive analytics? Please take a picture of this on your camera, on your phone, and it will take you to that link, and you can register your answer. That was the first question that we had. The second question was, what's the topmost skill to be a good data scientist in your point of view? Was that being a programmer? Was that being a statistician, a problem solver, or out-of-the-box thinker? What do you think? Please, again, all you need to do is take your camera of the phone and point it there, and you'll be able to go to the place where you can actually register your answer. The third question was, think of the most meaningful analytics projects that you've worked on. How was the project initiated? Whether you saw a need and started working, whether your manager requested it, or an executive requested it. Again, just scan this particular QR code and it will take you to that particular location and you can register your answer. And those were the questions that we went through today. All of you guys, thank you very much for being here and watching this episode. Hopefully it was of value to you. Again, if you're watching this on Twitter, please press the follow button so that you can follow me and you get alerted when the next episode is on. If you're watching it on LinkedIn, please follow me so that you're alerted for all the LinkedIn lives that I do. If you're watching it on YouTube, then please smash the subscribe button and also the bell icon so that you get alerted when a new show or a new video. I do upload a lot of videos on there as well, which makes it that we've got around about 70 videos at the moment on YouTube, which you can watch and learn from these, from the leading ladies of data science. There have been 42. The AI startup series that I run, which is now 7 episodes as well. And then there are other YouTube videos that I upload on regular basis, talking about AI in agriculture, talking about AI, talking about data science, analytics and stuff. So we'll give you a good idea of, where things are at. And finally, if you're watching it on Facebook, please like this and share it. Sharing it to Facebook groups is even better. If you can do that, that'll be great. More and more groups you share to, which are data science focused, more and more people will learn from these episodes. So thank you very much for watching, and it was pleasure having you guys on this show. Thank you, and bye now. I'll see you next week.